Hello, welcome to another Dave Makes Stuff with nTop tutorial. I am really excited to share this design with you. This is an artichoke. I know that if you work in aerospace, engineering, or medical industries, you probably don't have much need for an artichoke in your work, but it was a really fun project, and I think really showcases some of the capabilities of nTopology. So I wanted to share that with you. Some of the processes behind it, the custom blocks, and hopefully you'll find something in here that's applicable to your work, and maybe you like artichokes and you want to make artichokes, and that's great too. Anything that I do here, I'm more than willing to share. If there's custom blocks that you like, we'll figure out a way to get that to you. So just before we do a little overview here, I just want to explore the artichoke here. So this is I'm going to show you three different versions, one with 30 petals, or bracts, I think they're actually called in artichokes, 30, 45, and this one here is 60. So just right off the bat, it's nice to appreciate that pattern. It's called phyllotaxis. It's the mathematical pattern that petals form. Quite interesting, based on irrational numbers, pi, golden ratio. This is actually based on the square root of 2. We can play around with that a little bit further on. So there is 60 petals, and then a 30 petal. And the number is just an input variable into this, makes it a little bit more of an open one. And then in between, 45 petals is kind of like that. So let's get back to our 60 petal one here. And just going down the notebook here, these are all areas that I'll go into a little bit more depth in a second, but just so you know what's coming. In order to make this, each of these petals or bracts is actually unique. So the first bract that's formed in the middle is different than the outer or last bract that's formed here, and so this custom block will actually generate. We define the inner petal and then define the outer petal, and it will actually generate all of the petals according to growth pattern in between. So we'll look at that. That's a custom block that I've made, the petal generator, and then we'll talk a little bit about this texturing. Nothing too complicated, but turned out really well, I think. And then we will talk about how the petals are positioned on the receptacle or the heart, and that again is another custom block, and then we'll take a final look at the completed project and how it's made for 3D printing. Let's take a closer look at the petal generator custom block. And here's one of the reference petals. This is the outer petal. If we just open it up and look, we'll look at the outside of it. You can see that each petal is generated from 18 variables. So this gives a lot of flexibility. You can basically make any petal with this, from more complicated flower petals to more simple like bract type petals like this. Let's open it up here and explore around inside a little bit. So this is just the petal that's generated inside of the custom block. And you can see, so we'll go through some of the reference geometry first, and you can see how it's built up. So at the bottom here, you can see that the base is just the origin point, 0, 0, 0. And then at the tip, we define that where that is with the length. And then the center point in the middle, and that's just on the plane there. It's the point where that bulge is the biggest. And then the other reference point for the bulge is right there. That's where the bulge is, and those are our main points. That's the length, that's the width, and then we have a base spread guide. So that's just how how open it is at the base there, and the tip spread guide. So the tip can also be opened up. And then the mid bulge guide is that spline that forms the bulge in the middle, and the base bulge guide, which is which is sort of defines that boundary edge of the mesh along the base. Now, one thing you're probably noticing here is that this reference geometry doesn't actually line up with the edges of the mesh there, and that's because if you look down here at the petal from the top, you can see there's actually, I call it a sort of a cupping geometry that happens here, where it's not just flat, but it sort of cups in. It's a fairly common sort of look of petals, and it's defined up here by the cup angle. So 160 degrees is actually this angle right here. And so taking that, all of that reference geometry, we actually kind of readjust it so that the points don't lie just creating a flat petal, but this sort of cup geometry. So the tip cupped start points there, and then there, and you can see how all of those are lying on the actual boundary edge of the mesh. That one and that one. And then if we go down here, we can actually see all the tip points and all the midpoints and all the base points. And let's just clean things up a little bit here so we can see the next step. Just going to get rid of all these sort of simple reference points. So you can see all of those lines there, and what those lines allow is to create some splines that follow the points, but then also follow a series of input tangents that are in here too, from the base to the middle and the edges. And then I have a custom block that takes a array of splines like that and just builds a mesh into it like that. So that's kind of the overview, but let's play around with it a little bit here. So let's erase these points and go up to the very top, and let's just change the length here. So length change does pretty much what you would expect. Generates a longer leaf or longer petal. And let's just go back, and width, of course, is going to make it wider. And we'll just go back. The center point, now if you watch the profile here and we change that center point, whoops. There you can see that it's moved the bulge up further towards the tip of the leaf. We'll just return to the regular one. And so here is this cup angle. So right now it's at 160, and let's make it smaller so we can create even more of a cup there. We'll put it down to 120. And so there you can see it's quite a cupped leaf, but it's a neat effect how you get these really complex curves that define the edge of the petal. Let's put it back to our base one. The tip spread, of course, makes the tip open up a little bit. And let's put it back. And the tip tangent strength. So here you can see all the way down, there's tip tangent strength, tip tangent angle, mid tangent, just different strengths and angles to the different tangents that define these the reference splines here. And that's where you get some really interesting results here. So let's just change the tip tangent strength from 5 to something outrageously larger, like 20. And so you can see that really sort of puffs up the top there. The tangent angle, that's the tangent is right now 30 degrees down. Just for the sake of fun, let's change it to 30 degrees up and see what happens. So now we're getting fairly unpetal-like shapes here, but nonetheless, it just speaks to the range you can get. Let's go back to our basic one here, and the mid tangent strength is 15 right now. I'll show you what happens when we change it. Again, let's just go wild and crazy here to 50. Oops, I think I showed that to you in the wrong orientation there. So there's what we just changed it to, 50. It basically just blows out that mid bulge line there and makes it quite straight up and down. And again, just to compare here, back to 15 gives us that. The mid bulge depth is just puffing out that centerpiece like that. And then the base spread, base tangent strength, and base tangent angle, they function the same way as at the tip there. It's just affecting how the reference splines direct outwards from the base. The next fun variable is the edge, defining the edges. So defining the vector strength and the vector angle, and let's just see what happens when we change. The angle is, let's do that first. So it's 0 right now. It's pointing. So the edge is start tangent is just straight in the negative y direction. I can't remember what happens with negative versus positive, but let's just go to 30 here. So you can see that's just really flattened it out. Let's go to negative 30. And there you can see it's just creating more of a curvature around the edge of the spline. And of course, adjusting that, the strength of that just creates even more of a bulge. So let's return to our base petal there. And then the next, the bulge vector strength, if we change that, you can see that it just flattens out that the base there in sort of the x direction there. Putting it back, and then the last two variables here are just the number of guide splines that I showed you before that are distributed across our, and the number of mesh sections. So that's in the z direction here. How many little mesh quads are formed there. And I usually try to keep that pretty simple, because I find with the mesh that's produced, I can just use the refine meshed block and it will smooth things out fairly well. If you put this up, it's quite computationally intensive. So there you go. There's the petal mesh generator. And let's head back to the main notebook here. So like I mentioned earlier, that's the outer petal and that's the inner petal. And this next block here is really where the magic happens of having a custom block like this, because what it lets me do is say, okay, for the inner petal, I want that to be the length 70, but the outer ones are less, they're only 55. And so I can use that custom block to then create a sequence that varies according to the number of petals between those two values, 55 and 70. So basically in this block here, what I've done is I've outlined all of the parameters for the outer and the inner, and for all of the ones that change, some of them don't, the center point remains the same, but for all of the ones that changed, I've created variables that cycle through between endpoints, start points and endpoints, and according to the number of petals. And what that gives me, these are all bunched together, but basically those are all of the petals. They haven't been distributed yet, but that's what we're going to have to work with. And from those mesh petals, we can create, use the mesh to create a graph and then into a lattice. And so there we have the same mesh petals with a little bit of volume added. And as you can see, there's some texture been added too. So the texture field that I used to create this is basically a simplex noise field. But you can see first of all, I've squished it up, and then you can see I've used the remap block to spread it out as it goes upwards, and that creates that sort of flare. I also have variables in here that create a minimum thickness for FDM printing. I wanted to be assured that I could at least have the width of the nozzle there as a thickness of the leaf, and then the maximum base texture is 3 millimeters, and then the maximum tip texture is just 2 millimeters, so that the leaf does in fact get a little bit thinner as you move towards the tip. So this next part here is where we take all of these petals, 60 of them that have been generated in all their stages of growth, and we position them around the heart of the artichoke, or the receptacle. So I'm going to hide those and go down here and show you what the positioned petals look like. So here's the petals arranged around the points in that phyllotaxis pattern. If you if you look at this at the cross section of it, you can see that there's a lot of hidden internal geometry there that is first of all, it's not going to be seen, and it just complicates the model. So in the final, when I'm preparing this to print FDM, I'll show you in a minute. I just take out a lot of that internal geometry and just leave only what's visible on the outside there. So hiding that for a minute. Here's the base there, the receptacle, the artichoke heart, and you can see here a custom block that projects the points in a phyllotaxis pattern like that, projects them up to the surface of the sphere, and with this custom block here, we can change, how many. Let's just bump it right up to 1,000 there. How many points we have there, and maybe we'll make make it a little bit bigger so we can see them all. And so there you start to see a pattern that might remind you of sunflower seeds or something like that. So fun custom block to play with, and then that's what's used to project the petals up onto that surface. So let's just hide those, and we'll go back to the put the petals up like that, and then this inner fill here is just a piece that fills up the inside portion there, and then we can turn that off and go right back up to our final artichoke form. So there you have it, and thanks for listening. I don't know, if you're a aerospace engineer or a medical engineer, I don't know if you'll have much use for an artichoke in your designs, but I hope you found something here that was useful, or at the very least interesting. Thanks for joining, and stay tuned for the next one.